Okay, so right now, if you would turn in your note-taking guides to page 16, we are going to do the lesson on solving linear inequalities. And first of all, the vocabulary is, it's important to understand that the solution to a linear inequality is not just one value. Because it's an inequality, it's going to include a region. And then also, because these are linear, the word line is in linear, this is going to include a boundary line. So there's going to be a boundary line and a shaded region. So let's review what kind of lines or what kind of inequalities means what kind of boundary lines. So if we have a less than or greater than symbol, what that means is the boundary line is not included in the solution, and so we indicate that with a dashed line. So the dashed line is not, the values that are on the dashed line are not included in the solution. If we have a less than or equal to, less than or equal to, greater than or equal to, that is a solid line. And that would mean that the points that are on that line are included in the solution. Okay, so what we're going to do is write down the 3 steps that are going to be our procedure for graphing linear inequalities. The first step is we're going to graph the line. There are 2 types of lines that we have graphed, and we're going to use 2 different methods. One would be that one is in slope-intercept form, and then also things that would be in standard form. So when after we graph the line, we are going to make sure we look at the inequality sign, and we're going to choose dashed or solid line. Then this is where the region becomes important. The line is a boundary line to tell us which region is included in the solution. So to pick the region, we are going to choose and test 1 point. I'm going to choose and test 1 point. Then we are going to shade accordingly. Okay, so let me show you how a test point works, okay? Example 1 is just about testing a point. What we do is we put this first point, because it's an x-coordinate, in for x. And then we put the second coordinate in for y. And we check to see if it makes the inequality true. So if I were to rewrite this, I would have 3 times negative 2 plus 4 times 5 is less than 8. So that gives me negative 6 plus 20 is less than 8. Negative 6 plus 20 is 14 is less than 8. Does that make the inequality true? Is 14 less than 8? It does not. So the answer to this would be no. Negative 25 is not a solution. And this would be the work. So that's kind of how a test point works, and we often, if we can, we pick some easier numbers to work with the test point. So let's take a look at something that is in slope-intercept form. So y is greater than negative 2x plus 1. So I'm going to go ahead and graph this like I normally would. It's a boundary line, and I'm going to put the y-intercept of 1 on the graph. This slope has a slope of negative 2, so I'm going to go down 2 over 1, down 2 over 1. Now, since this is a greater than sign, that means that the line, the boundary line, is not going to be included. And so what I'm going to do then is I am going to connect these points with a dashed line. Okay. A dashed line. Now I have to choose and test one point, and so your point has to be, so there's two regions here. There's kind of up to the right here, that could be the solution, or down kind of to the bottom and left. You can pick any test point you want. I'm going to pick 0, 0, and very clearly 0, 0 is right here. So it is kind of below and to the left. So I'm going to check 0, 0 and see if it makes the inequality true. I put 0 in for y, greater than negative 2 times 0 plus 1. That would mean 0 is greater than 1. Is that true? It is not. It is false. So 0, 0 is not a solution. That means this region over here is not the solution region. That means the other side is. So if the test point, the point that you test, is false, you are going to shade on the side that is not in the test point region. So the solution would be the dashed line and everything kind of above and to the right of that dashed line. Alright, so let's check another one. So for this one, I am going to use, you can change it to slope-intercept form, but I'm going to use the intercept method. So I'm going to find the x-intercept and the y-intercept. So I'm going to put 0 in for y, and I'm going to pretend like this is an equal sign, only because I'm graphing the boundary line. And so when I'm graphing the boundary line, I pretend like it's equal, but then I address that in the shading. So I get 4x equals 9, divide by 4, x equals 2.25. Okay, so that's the x-intercept. For the y-intercept, I put 0 in for x. Minus 3y equals 9. I divide by negative 3. Y equals negative 3. So that's the point 0, negative 3. So I'm going to plot those 2 points. So 2.250 would be right here. 0, negative 3 would be right here. And this is going to be a solid line because it's greater than or equal to. Okay, so once again, now I'm not done here because this is just the boundary line. So either the solution is going to be up here, above, and to the left of this line, or below. So now once again, I'm going to pick a test point. And I can pick any point I want. 0, 0 is really easy to work with, but I'm going to just show you, what if I picked something over here, okay? let's say I picked 3, negative 2, just so you see it works for any point. We would plug 3, negative 2 in, and we'd see if it makes it true. 4 times 3 minus 3 times negative 2, is that greater than or equal to 9? 12 plus 6, is that greater than or equal to 9? 18 is greater than or equal to 9. Is that true? It is true. So what that means is this point over here is in the solution. So if the point you test makes the inequality true, you are going to shade on the side of the line where that test point lies. So I'm shading on the same side where 3, negative 2 is. So the solution is that green line, and everything that would be in this shaded region. So once again, let's review the test point. If the test point, like above, does not make the inequality true, you want to shade on the other side. That means that this is not the solution. If the test point does make the inequality true, that means the side of the line that you are currently on is the solution side, and so you would shade this side of the line.